In the previous modules, you've learned how to pre-process data and build both supervised and unsupervised machine learning models. Now, let's focus on an essential step in the machine learning workflow: evaluating and validating your models. This ensures that the model you've developed performs well not only on the training data, but also holds up when exposed to new, unseen data. Throughout this module, you'll grasp various techniques to assess the performance of your models effectively. Understanding different data splits by training, validation, and test sets. Training set. This is the data on which your model is trained. It learns from this data. Validation set. This set is used to tune the parameters of the model. It helps in selecting the best model version that neither overfits nor underfits. Test set. This is used only at the last stage to assess how well your model performs on unseen data. It's critical for getting a real-world measure of your model's performance. Importance of data splitting. Using these distinct data sets helps you mitigate the risk of overfitting and gives an unbiased evaluation of model performance. You'll often use a ratio like 70% training, 15% validation, and 15% test to split your data, though these ratios can vary based on the dataset size and specific requirements. What is cross-validation? Cross-validation is a robust method for estimating the model's performance. Instead of splitting the dataset once, the data is split multiple times into training and validation sets, and the model is trained and validated against each combination. Types of cross-validation. K-fold cross-validation. The data is divided into K subsets. The model is then trained on K-1 subsets and validated on the remaining subset. This process is repeated until each subset serves as a test set. Leave one out cross-validation, or LOOCV, is an extreme case of K-fold cross-validation, where K equals the number of data points. It's especially useful for small datasets. Now let's understand metrics for model performance evaluation, which are classification metrics and regression metrics. First, let's understand classification metrics. It deals with accuracy, proportion of total correct predictions, precision and recall. Precision measures the accuracy of positive predictions. Recall or sensitivity measures the ability to find all relevant instances. F1, score harmonic mean of precision and recall. ROC-AUC graphical representation, showing the capability of a model at distinguishing between classes. And now let's understand regression metrics. It deals with mean absolute error, or May average magnitude of errors in a set of predictions without direction. Mean squared error, or MSE average of the squares of the errors. It is more sensitive to outliers as compared to May. R squared provides an indication of goodness of fit, and therefore a measure of how well unseen samples are likely to be predicted by the model. Detecting overfitting and underfitting. Signs of overfitting. Excellent performance on the training data, but poor model performance on new, unseen data, and excessive complexity in the model with too many parameters. Signs of underfitting. The model is too simple and both training and test scores are low. The model does not capture the underlying trend of the data and fails to learn from the training data. Strategies to avoid overfitting and underfitting are: pruning, in tree-based models, reducing the size of the decision trees. Regularization, adding a penalty on the different parameters of the model to reduce the freedom of the model, hence overfitting. Using simpler models. Sometimes simpler models may result in better generalization in practice. Cross-validation, using robust cross-validation techniques to gauge the efficacy of the model on unseen data. In this module, you've learned the crucial concepts of model evaluation and validation. Understanding these concepts will help you in effectively training models that are not only good on paper, but also perform well when deployed in real-world scenarios. By mastering these techniques, you're one step closer to becoming proficient in machine learning. Continue practicing these skills to enhance your problem-solving capabilities in the field of AI and machine learning. Thank you so much for taking the time to watch this online training module. I hope you found it valuable and insightful. To stay updated on upcoming content, including new modules, case studies, and quizzes, be sure to subscribe to my channel and share in your community. Your support helps me create more content that enhances your learning experience. Don't miss out on the next steps to watch other module videos to deepen your understanding and apply the concepts in real-world scenarios. Thanks again, and I look forward to seeing you in the next video.